call the work session to order. Ron?
Great. Thank you, Mr. Mayor, City Council. What you have before you tonight is a work session on our new water treatment plant. Kind of give you an update on where we're at, some consensus stuff. I guess before we get too far into it, I'd like to introduce some new faces that maybe you haven't seen. We got Wayne Gresh here. He's the project manager for the project. He's with Corollo Engineers. Jen Menton, who is one of the designers on the project. And we have Jeff McGraw with MWA Architects, who's the lead architect. And then we've got Chad Sanderson with MWA Architects as well. And then I don't know if most of you know Mike. Mike works with us. Mike's one of our project engineers. I asked him to join us tonight, and he's probably the main guy on this project as well for the city, with myself and Rob. So with that, we'll get into it. Basically, the purpose of tonight's, again, is to give you an update on schedule, status of where we're at, where we've come from. We're going to have a membrane system procurement award recommendation later on in the regular agenda. We probably won't get into too much detail during the work session, so we can save time for really what we want to update you on and get some consensus on. We'll give you a little bit of idea on the status of our permits, how that's going. And again, like I said, the presentation on the building architectural program, that'll give you an idea of what we're looking at, where we've come from, and get a consensus from you at that point. And then last, give you an update on funding and the estimated project costs, where we're at. And again, you'll see some funding packages coming to you later on tonight in the regular agenda. Background, back in November 2014, this council executed an amendment number 2 to our existing design contract with Corollo Engineers. That amendment was to complete all the environmental studies and a preliminary design of a raw water pump station and a river intake. And it also included submission of our joint permit application to Army Corps of Engineers, Division of State Lands, and every other agency under the sun that has their fingers in this for buy-off. So far, we're on track to receive our permit in April. We've gone through several commenting periods, and at this point, none of the comments, they're very minor. Without getting into any details, most of them don't even pertain to what we're doing on the project. So with that, we also began our water rights transfer, and I call it a transfer. Basically, it's a point of diversion transfer from our original intake at the dam out on River Road down to where our proposed new raw water intake is going to be located. That's on track. In fact, it was advertised this week in the Lebanon Express for public comment. Should we receive no comment in 30 days, it goes through another 30-day protest period. If that works out like we expect it to, we should have the final order in January of 2016 for our water rights transfer. So that was one, if you remember back, that was one of the key elements of this that we thought was going to be one of the bigger setbacks, could be a bigger setback, and it looks like that's going really well. So since that November amendment execution on number 2, basically you've got a project now that includes a river intake, a raw water pump station, a raw water pipeline with call it a line coming off of it to fill Cheetah Lake as opposed to filling Cheetah Lake out of the canal right now. So we'll be able to control that without having pumps in the canal or having to deal with Albany. In such cases, we'll still have to deal with Albany and how we manage Cheetah Lake and the berm there together. You'll have a water treatment plant. Of course, all the utilities that go with that. You know, we have transmission mains, sewer mains, and everything else that goes with that. And none of that stuff has changed much. And then also, there's a restroom that'll be going in out at Cheetah Lake. That's not part of this project, but however, we will be putting the utilities to that project as we come through there. And of course, all the site work and everything else. So with that, I'm going to turn it over to Wayne, and I'm going to let him fill you in on kind of the design status and where we're headed next.
I'll use some. So in your handouts, there's a slide that at the bottom of the page called Design Status and Schedule. So we've taken the project elements and broke those up into 2 bid packages. Bid package 1 will include all of the pipelines work, raw water pipeline, the water transmission main, sanitary sewer, and then the bid package 2 will include all of the facilities. So that's the intake, raw water pump station, water treatment plant. And we broke them up that way so that we could get the best contractors on both projects. We've got contractors that do underground work on the pipelines and facilities work on the facilities. Those projects will advertise roughly the same time in April. Right now on our schedule, we've got April 19th penciled out for that bid date. On the project itself, we're at a point where we need some decisions by City Council, and those are before you. One is we've worked through the membrane procurement period, and we've got a recommendation before you on awarding that contract. And we also have our amendment before you for the final design services tonight. The overall project schedule shown on the bar chart is we've got and this is under our scope of supply. So we have the 404 permits with Department of State Lands and Corps of Engineers, and those are on track. The membrane procurement will officially end with the award of the contract and the final negotiations this month. And then we have completed the preliminary design services and reviewed that with the city. We're ready to submit that document to the state. 60% is scheduled to be completed out just at the end of this year, early January, 90% then in April, and then we will go through the bid and award period. The formal review of the project documents is required by the Drinking Water Services, and we will officially have that at the end of the project, although we have asked them to start their review with the preliminary design and the membrane award, because the membranes are such a significant part of compliance with the regulations, and they've agreed to do that. The 2 bid packages will coincide at the start, but bid package 1 won't take very long to complete. We want that completed in 2016. The plant, with the construction, the commissioning, and everything, will take us to about the end of 2017. On bid package 1, the routes have been selected. Our surveying work will be complete this month with the section of River Road. The geotechnical engineering, the borings were complete. We're now getting the data and the engineering reports on those, ready to move those into final design. And then we have 2 formal submittals, 60% and 90% before the advertisement. Bid package 2, we have the intake on a separate track from the raw water pump station and the water treatment plant, because it has to go through 2 formal reviews with the federal agencies. And so its track is 60% is here in November, then it'll go through a 30-day review period, and then another one in January. And it will then be folded into the design documents. The intake itself is, I think you've seen it in some of our earlier presentations, but really it's just a structure that's going to sit on the bank of the river. And this is a cross-section of it. The way it's set up, you have the river in here, you have a small zone where the screens are, you have a protected area where we have mechanisms under there for the backwash equipment, for the flooding and the flood stages that come up. Then we come on up, there is a workroom because we have control valves, control panels. Those will be enclosed in a room. And then just the drive surface up here off of River Road. And the pipeline that comes out of that will come out deep underneath the roadway into the raw water pump station. The raw water pump station and our treatment plant, we are in the final design stages of that, or ready to do that work. We have went through the membrane procurement. The architectural program has been fairly well developed. We're going to present that to you tonight and ask for your consensus on the direction that we're headed. And then we're going to complete that work out.
Can I ask a quick question? On that last, if the dam breaks, if Foster Dam breaks, is this set up to survive whatever that with?
Honestly, we didn't look at the inundation zone if the dam breaks. We've got this set up so that it's protected well above the 100-year floodplain, but I don't know what the inundation map would look like for that failure.
I believe a lot of it would depend on how much the water is in Foster Reservoir. And Foster Reservoir, if I remember back right, was maybe a 100-year event if it broke.
Something close to that.
But if the big one, I believe, was Green Peter, in which case it's
Pretty much that piece.
A lot of us aren't going to care.
I would say if this is damaged, there's going to be a lot of damage in Lebanon.
it may be a release part.
But
Okay, so now, I guess before we get into the architectural piece, I'm going to continue on through the slides here as far as project costs and funding, everybody's favorite subject. If you see the design cost, we're sitting at a little over $3.5 million. That is including the amendment that we will be requesting approval for tonight during the regular council session. It includes everything to get the projects out on the street up to beginning of construction. At which point, and this is exactly how we framed it to begin with, we would come back with a design during construction services as well. It equates to a 13.9% design fee, which is well within industry standards. We monitor this stuff. If you look at our estimated project cost, we're looking at about $25 million. If you go back to the master plan, Rob and I were looking at that the other day, it was in that range as well. However, the master plan didn't include a river intake and so on. It included going off the river. So we're right there in that area. Go ahead.
The 25 includes the design costs?
No, the 25 does not.
28 plus.
That's strictly construction costs there, yes. I would estimate the numbers that we're using for all of our financial purposes were in the $30 million range for a total project. And that includes all the design fees, that includes construction and after we get the thing built and pushing it through. So that's about where we're at. The one thing the $25 million here does include is 20% in contingencies. That's a big number right now, but again, we're at 60. We're moving towards 60% design. We're being conservative in that number, and obviously we'll hone in on that as we get closer to final design. It does include also an alternative for pretreatment. We're using membranes. One thing that we've worked through with Carollo is the possibility of using pretreatment, such as a settler, to settle about 2 million gallons of our water a day. The reason behind that is it increases filter life, and we would use it during high turbidity months, during the winter when the river's flowing chocolate milk. It'll give us an option to clean a majority of that water, or at least settle out a majority of the water before we run it through the filters, and it just increases the longevity of the filters and helps with the O&M costs through that. Yeah, and that's on a deductive alternate. Like I said, we're bumping right up against what we have and what our project costs are, so we've put that on an alternative. Whether we do that or not, it's going to depend on where we're sitting with contingencies and where our construction costs come in. So stay tuned for that. Go ahead.
Question on the cost.
Yes.
What was the approximate cost extra for the intake off the river?
Well, I don't have that number with me. It's somewhere in the, I think if you take design fee and everything else, we're probably looking at somewhere around 10 million. Yeah, which is right in that ballpark. I think we were estimating somewhere, when we originally did the preliminary, it was somewhere in the $8 to $12 million range we were looking, so it's right in there. Good news is project funding. We'll be coming to you tonight with some loans that we've gotten through IFA. We've basically gotten $21 million in loans. A portion of that's forgivable principal, and I won't get into too many of the details until we get to the actual agenda item. But low interest rate, we've been able to put away the $6 million in water funds out of our water utility. I'm sorry. We're projecting probably to have somewhere in the neighborhood of $500,000 in SDCs, and of course the Northwest Urban Renewal District is one of the projects, obligated $5 million. We're using $1.6 million of that, and we used the other $3.4 on the reservoir. And then you see the sewer utility fund, we're proposing to use a portion of that to pay for the sewer that's going in for the project. So you can see at the end I put project costs outweigh project funding by approximately $1 million. That seems huge and whatnot right now. I guess to us it seems like we're right on track. We're still with 20% contingencies, and it's too early to tell, and that's why we've done an alternate for the pretreatment.
One thing to focus in on as well, in the project funding, the forgivable principal is basically a grant.
Yeah.
The state can't give a grant, but they can kind of backdoor into a grant by forgiving principal.
Right.
So that forgivable principal was about $750,000. So that's,
And we'll cover that during the ordinances that we go over with you later on tonight. Is there any questions on the first part of this presentation, costs, where we're at, where we're headed? Anything come up there before we get into the architectural program? Okay. Well, with that, I'm going to turn it over to Jeff and Chad, and they will give you a presentation on building architecture.
Thank you. Okay, so we're going to be balancing people who can see the screen and people who can't. So I'll sort of just describe where we are along the way. Jeez. That guy there.
So this should be your second handout.
Everybody ready? Okay, those are the architectural topics that we're going to be talking a little bit about tonight. We've been working on this project now for a couple of years, and we'll show you the progression of what we've been doing. The last item there is raw water pump station. You guys are probably familiar with this terminology by now, but so that's our agenda, and we'll kind of speed through things. This is the site plan, and it is an engineering site plan. This is paving. This is River Road. This is future Gilbert Road. This is the water treatment plant building, and this is an early footprint. The administrative areas are here. The process areas are here. Back of house maintenance and that sort of thing are on the north side.
Can you move that, Joe?
I'll wait.
Thank you.
Man.
Oh, thank you.
So when we do buildings, municipal buildings or any buildings at this time, the most sustainable way to do these buildings is to orient the north and the south faces of the building, the long sides of those buildings, north-south. And so this was a conscious effort in orienting this building, which gives us some sustainable benefits in building layout, in mechanical systems and such. But as far as circulation goes, this is the main entry to the plant at this location. There would be parking in this location. There would be bus parking, a security gate in that place, and then a place to drive through for chemicals and back-of-house activities. But for the most part, the front of this is going to be landscaped. There'll be handicap parking in that location, but far enough away from River Road that the traffic engineers won't yell at us. So, questions on that? So this is the building footprint, and it is a very, I would say, innovative layout of process piping and such. This is the big key in doing buildings like this. If the process piping is efficient, the electrical duct banks and the runs are efficient, the building itself becomes very efficient. As mentioned, this is this administrative core on the south side, which is an entry in this location. This is a glass wall, so you're able to see into the membrane room. This is where the high technology is, and these things are actually quite beautiful when they're installed. Electrical in this location. These are chemicals. This is for pumping. And the back of house, which is where people come in that are service-oriented or operators, would be driving their trucks, parking in the back, and there's individual shower rooms and bathrooms in the backside through a general mudroom. But this circulation is sort of clean. We like it. It goes right through the middle of the building. This is also circulation in this way, which will probably top light or something. But the idea of a control room here, a little laboratory, which is required by regulations, and one office, a training room, which is set up to show maximum capacity, but normally there'd be a conference table in there, a little break room, and a handicap or accessible restroom right off the lobby for school tours and such. This is sort of back-of-house area as well. This is sort of a screened area where there'll be generators and mechanical equipment. No mechanical equipment should be on the roof of this building. Why don't I stop there and see if there's any questions?
This other square is additional membrane, so
Right there.
if we needed to expand.
Correct.
So we'll start with 4 with room for 5, is that what I read here?
Yeah, so in terms of capacity, what we'll end up with, and one of the things we'll be talking to you about tonight in our work memories, but for intensive purposes now, we'll be looking at 4.5 million gallons a day right now. That's what our firm capacity will be. With the capability with those 4 racks that you see there that are lit up to go to 6 million gallons with just screwing to that. And with adding that other one, where it's at this dash line, that will be able to go to 8 without even building
So what, and maybe this is a discussion for later too, but at 8 million, what is our population?
It depends. It's
Residential versus industrial mix would be difficult.
It's not going to drive our capacity issues. It's going to be more industrial. So if you don't see any more industrial, I mean, we've got a peg, our bill got it, 14 inch. I don't know how we ever get there.
We could expand to 14?
If we wanted to.
If you wanted
I mean,
to.
but that's, I mean,
We could with this plant by pumping the wall that's to the left of the dash line, pumping the wall out that way, adding more racks.
So 20 years from now, when we're all dead and somebody else is worrying about all this, there was foresight enough for that to...
unless there's some big major industrial user, if we just continue the growth pattern that we're seeing right now, my guess is that this plant will never see 14. I mean, everything will be set up to where that it could, but at that time, our intake is going to be designed for that as well. But my guess is that, unless there's some big industrial user, we won't see it on residential.
And 14, the master plan projection build out for 14 was 2050, something in that, 2055, something in that. I mean, many years down the road. And this plant...
I'll be dead.
Yeah.
Might be.
You don't have to worry about it. We won't do that.
Not my problem. Put that in the minutes.
The structural design that you're putting together has a lifespan for this plant of how many years?
We designed for somewhere around 100 years. It's not the processing equipment, but most water treatment plants, wastewater plants, have about 100-year life, and you can actually get more out of them. There's a good part of them are concrete structures. But it's really hard to get land for public facilities and sufficient space in that, and most often we just see expansion of facilities. And so that's how we set these up. And just by virtue of the fact that the building materials we're using are predominantly, we design these for critical facilities because water is essential for coming back, and so the structural designs are very robust. And that adds to the age.
Including earthquake?
Excuse me?
Including earthquake?
Yeah, we will design this for what's roughly referred to as the magnitude 9, which shakes for about 3 minutes. It actually, we look at all the hazards. You don't have, the biggest one for you is seismic, but you look at wind, you look at all of the hazards that could occur.
Okay. So another thing to point out about this plan, yeah, it's on. We work a lot in water, wastewater facilities. Designing a space for expansion now is pretty common, as opposed to leaving site for that space later. Price-wise, it always pencils out to allow more space for that. But the other thing I didn't mention is this is maintenance and this is storage in this location as well. So that's another component of this building. But the building is designed so that if this expands or if the chemicals expand, it can be extruded. And that was one of the sort of criteria we're thinking about. The other part of this is that we've got essentially low volumes and a high volume and a high volume. So when we start talking about where we've come from and where we are now, the challenge we have is that this is a big volume, this is a big volume, this is lower, this is lower, this is lower. So from a functional standpoint, mechanical function standpoint, this is a very efficient building. From an architectural standpoint, it's a little bit of a challenge, which we have our approach today. So this is where we started from. These designs were developed prior to 2014. Sorry, Wayne. And this is for a membrane facility as well, and had chemicals outside. And last year, when we started working on this facility, this became a sort of a volume study where the administrative facilities were on the south side as well. Some of the larger volume areas were in the front, and we did this sort of shed gable sort of scenario. So this is sort of where we came from, but these sort of sliding volumes with circulation going this way. And in this case, we had sort of offices and administrative facilities and showers in the middle. We've evolved. So now with this current layout, I mentioned it was a little bit of a challenge. The membrane area has a 20-foot, and the chemical area has a 20-foot minimum clearance to the top of machines. This enables people to stand on top of chemical tanks and stand on top of membranes. So this volume and this volume are tall. Some of these other volumes are, as you can see, 12 feet, 12 feet, 12 feet. Pump room is less, 15 feet. So this became the challenge of designing a building that had larger volumes here that needed to be serviced by forklifts and things like that, and then thinking about a structural system that was efficient. So we looked at flat roofs first. I think everybody's familiar with flat roofs. There's not a lot of wasted overhead space in a flat roof, but I think this would be kind of an interesting, probably mundane or industrial-looking building if we went with flat roofs. And you can see how we've sort of cut sections. That's A and that's B. Then we looked at gable roofs. If we just covered this building with one big gable roof, which is possible, what we wind up with is these, what we call dead zones. These are areas we have to condition over the next 100 years, which means air gets treated, heated, cooled, conditioned in those spaces. And these are the program elements below, so you can see the minimum space requirements for those. So there's a lot of wasted space in a big gable, plus you're looking at a big roof. So then we looked at shed roofs, and this is sort of where we started back in 2014. Also, some benefits in terms of letting light in high, but lots of space available that we have to condition, not to mention our structural engineer really doesn't like that wall because it's so tall. And again, Wayne Gresh here mentioned that this is a Category 4 building, which basically means immediate occupancy as defined in the code. So this has to be a robust building. The heavier we make it, the taller we make it, the harder it is, the more expensive it becomes. So we've been working with Carollo and trying to really dial in a structural system that works. And this is one we like because it's sort of a hybrid. The lower volumes are flat roofs. The taller volumes that I talked about previously are these offset gables. We call them offset gables, where these are essentially frames. They're steel frames as opposed to a long supported wall and a long truss element that would be quite deep. So these are frames at an interval that's something like 24 feet on center. But the idea of dealing with these larger volumes is very different than these smaller volumes, and coming up with a post and beam kind of system for the smaller volumes seems to make sense. So if we take that last diagram, is everybody good so far? Any questions? If we take that last set of diagrams, and this is the lower volumes, and we're thinking, as I said, of a post and beam, kind of a wood frame system, glue lambs, and wood elements that would be from the Willamette Valley, using what we're famous for here on the lower volumes. This is a view of the control room, which is one of the south-facing operations areas, and a view into this membrane room. You can sort of see how that would go. So the lower volume looking into a higher volume. This is the membrane room, and this is one of those higher volumes, but notice that we've got side light coming in here, which enables us to turn the lights off during the day. And this is very similar to the way this room will lay out. These are from the computer models, and we haven't really given it much thought. There's no real interior design going on yet in this facility, but we thought we'd show these volumes to you to inform, better inform how this facility is laid out. Large aisleways here for forklifts and for maintenance, durable surfaces on the side, but you can see sort of the open airy effect of that roof. Another picture of the chemical area, also showing that roof, and you can't see the side light behind, but you can see windows from this area here facing west. These are chemical containment areas. This is all, this is how chemical areas are laid out. You need a lot of space here to move things around, bring in totes from the backside, and make reports like that guy's doing. Another picture of the chemical room with the same roof line. This is the pump room, and you can see this is one of the lower volumes, but these are pumps that are serving the facility, and you can see, again, some of these access ways, service aisles for taking pumps out and doing regular maintenance. And then lastly, this is the view from the lobby, and the lobby has space for tour groups to come in, skinny children. Looking, that's our computer program.
Very toasty.
It gave us.
Girls are creepy.
Yeah, they are.
It is getting towards Halloween.
And the employees are very transparent.
That's good. That's good. All right.
That's right. Hey.
But again, the lower volumes using sort of a post and beam flat roof with transparent walls looking into the membrane room, and also going to the lab and the offices at this point. So those are some interior views. Again, no real interior design at this point. These are just sort of quickly put together to give you a flavor. So if you're familiar with the work we do, most of our buildings really look like they belong to their place. In other words, we do a little bit of research, we get to know the communities as much as we can, and then we design facilities that are regional and match climate and local materials and that sort of thing. So we did a little bit of a search here in Lebanon, and these are buildings around Lebanon. We found some exposed timber on your fire station, this glass entry with canopies. This is a big theme here. Obviously, it rains a lot. Large expanses of glass facing, select areas, north-facing glass. Standing seam. Standing seam is a predominant material not only used on roofs in a very high, aggressive way, by the way. You can really see the detail on these roofs. It's also used in wall treatments at this point. But we like this picture as well of a local school showing, shed roofs, defined entryways, flat roofs, shed roofs, and, regional materials. So from that, we've meshed computer models of the engineering work thus far and the architectural work thus far, and came up with a couple different ways to think about it. These are the flat areas here on this administrative facility. Administrative areas facing south. These are these large volumes we're talking about with these structural bents or structural frames. And this is sort of this offset large volumes I was talking about. So this became kind of an intriguing way and an efficient way to cover these facilities, and thinking about this standing seam actually covering this part of the facility and that part of the facility so that it sort of wraps the wall. There's another view showing a view towards River Road. We've got kind of a yard in this location, some screening. This will be interpretive related landscaping, the building entry in this location. But still, you can see how those volumes and that flat roof comes together. And I'm going to let Chad talk about materials. We going okay?
Is everybody like the building layout as far as the layout and the roof lines? It's different, but when we saw it as staff, we really liked it, and it was very efficient. I mean, they kept hitting on efficiencies, with the heating and the cooling piece. So I guess we're kind of one of those points where I'd like to get a council consensus on, roof lines and whatnot.
I'd like to start all over.
That sounds good. So then, back to the cost and the scope.
Yeah.
We need to modify that again.
I like the design. I think it looks good.
Yeah.
Looks really nice.
It is important to us because the next thing we show you is
The lowest point of the slope roof is still 12 feet above the grade.
Oh, in the back?
I like also the way that it's very similar to Riverview and some of our newer schools, where it's got the large area with the lighting coming in on that south side, which I think really helps for efficiency.
the other thing that they've done, the architectural part of this is limited the exposure on the south side of the roof, so you don't get a lot of heat load. You will get some heat load, and there's actually good places for solar panels on that steeper piece of the roof, but the back side of it is north-facing. So there's a lot of things in this diagram for those efficiencies that we're trying to build in, and but the importance is that it's not a conventional gable, and it's not that Walmart style that we started with. And so it's going to be a little different.
It's structurally efficient as well.
It's structurally efficient. It's efficient with headspace over our equipment and our layouts. And
As far as expansion goes, you don't have to completely rebuild it.
Right,
these-
you can actually extrude these volumes,
Yeah.
so that you can actually add another bay on this side or this side.
right.
Which is where the likely expansion would be if everybody decided to move to Lebanon. So,
In 50 years.
One of the things we had thought of in our treatment plant was the option to have tours and kids, and then I heard an interpretive garden maybe or something like that. Now, is there a thought of actually having an interpretive area where there is a learning place on how the water works and how is that part of it also?
You see a lot of tours, I mean, with water treatment plants, especially newer ones, and there will be that as they tour the plant, and they'll learn.
Okay, because it just seems like a great idea.
If you
It
go back-
just does.
I like those interpretive areas in the lobby where,
Right.
where.
Where like there's a
sometimes
small
it's
scale,
interactive
yeah, and you
or
can
it's-
actually do something with it. Almost like an OMSI kind of a thing. It would be kind of neat to have something like that.
Yeah, I wish I had pictures of eWeb's front entrance that was done recently. It's really good. One of the things that we will work with this entry area, this is where that's going to go. We really do want the school kids in here because that's the education part of this. We want them walking past interpretive type gardens, landscaping, xeriscape type stuff as they come into this entrance. So that landscaping will be out front. That's what we recommend. We're using a lot of monitors in these front areas now, so that that swing out from the walls, and then they can go through 3D models, they can go through a lot of pictorial type stuff, touch screens that they can walk up to.
Good.
What's the staffing model here?
Somewhere around 3, 4, somewhere in that neighborhood. We haven't gone through all those details yet.
Yeah, it'll be staffed during the day, it won't be staffed 24 hours a day. And our proposal is to automate it so that they have the alarms, they have the feedback with them, with the key operators all the time. But there'll be about 3 to 4 people running this plant during the daytime.
So any changes to that? Anybody see any changes?
Looks good.
Continue on.
So I'm just gonna, oh, that's loud. I'm gonna pick up where we start looking at that structural shape and to try to figure out what it's going to actually look like and how we're going to wrap the skin around it. And you saw in the previous slides that we showed some standing seam roof panels and how they can be both walls and or the roof. And we're talking about metal panels, so that's a close-up of what one looks like. We also have flat roofs. Traditionally, they were done often with a ballasted roof, which is a membrane that's protected by gravel on top. Recently, the technology's gotten a lot better, and we're using a lot of green roofs, which can actually provide storm treatment as well as a walking surface, and they are actually the longest lasting roof we can recommend because roofs won't fail if you don't let ultraviolet radiation hit them, and green roofs solve that problem completely. So they've had problems in the past when they first came out 20, 30 years ago, but they've really gotten to be what we think is the best roof.
How many dandelions per square feet do you need?
We'll put a lawnmower up there, we'll mow it.
But as far as, we're not green roof salesmen. As I said earlier, we've been forced to use them up north of us, and we've actually grown to love them, and they have some real benefits. But we also write in maintenance agreements that span 5 years and can be renewed, and they do need maintenance.
Yeah, I bet.
Go ahead. So then, for the walls, we wanted to look at a couple of different options. We've mentioned that we want to take advantage of passive cooling and some energy-saving ideas. The original versions of the raw water treatment plant used a CMU veneer or a brick veneer for some accents, so we wanted to start there. We also, the energy code is making brick walls a lot more difficult to build. You have to add metal attachments, and you have to do insulation behind them, and they're getting more and more complicated than they used to be. So we've started using what's called a fiber cement panel, which is basically concrete cast into wood slats. The advantage is that if you ever need to paint it, and it lasts, it's concrete, so it'll last a very long time. And if you chip it, it's still the same color, so it sort of doesn't heal itself, but the color stays the same. And then another product we're using is called a wood composite. This is where they take scrap sawdust and waste materials from the wood industry, mix it with resins, and it comes out as a different material that's made of wood. It looks like wood, and you can handle it like wood, but it's also got the color integral, and it's extremely long-lived. So those are some materials that we're using on a lot of our projects now. One of their big advantages is they're a lot lighter than brick and CMU, so it goes back to keeping the structure from getting too complicated. We also, as had noticed, that there was a lot of the aluminum storefront glazing around town. I believe the public school and the library both had that. And so that's what we're showing for the glazing system, and that's very common as well. So what does that all look like? This is what the CMU version would look like. This would be from the corner of River Road, looking towards the front of it. So
It's brick and, right?
Right, so the large volumes we did with CMU veneer, and the lower volumes we did with a brick veneer, which is a pretty traditional way to do this sort of facility, where you have a different material on the low areas and a different, more industrial one on the larger areas. And we thought this was pretty good, but we wanted to see what else would work with this, but here's a couple views. There's the south view of the front. You can see that all of the glass is actually has an overhang over it. So what happens? So basically, you don't get direct light from the south, but you get daylighting. So you don't have to worry about the rooms heating up in the afternoons. And then we have a view from the back of house. So you can see this would be the pump room here in the back, and then the membrane in front of it, and then chemicals over here. This is the locker and entry. So that's what it would look like with those materials.
Where is River Road?
So this would be the back of house. River Road would be down to the far left, sort of running left to right. So this is the northwest corner. This is from the River
My
Road.
question is, what's the view from River Road? What are people waiting?
It's very close to that.
We're going to see that?
That's nice. Well, without the landscaping, we don't have the landscaping trees. That's the...
Yeah, we intend to put deciduous trees along the south side to help with shading, and we'll do some plant screening along River Road as well, I believe is the plan.
That's correct.
And then it'll also be fenced, too. I mean, this is a secure facility, so you're not going to see, you're not a 6-foot chain fence up. You're not going to see, you're going to be able to see this. And the front portion of it, I don't believe we're doing secure fencing, so you'll be able to access this, but all the important areas will be secure.
How far is the setback from the road?
We've got a setback, 20 feet plus the building expansion over plan. We've got, what we've got right along River Road is a stormwater facility. So it's a stormwater swale.
Right in this area here.
And then we've got basically a buffer area that will allow us to do the expansion work in. Initially, that's all going to be landscaped.
Yeah, I think the thing you're looking at here is that we've got a generator and those sorts of things here. So we've got to come up with some sort of screening either on the building or in front of this area, so that the view from River Road is sort of, one building rather than a big hole in it.
Well, to answer your question, while we're on this slide, there's another aspect of it that we really thought was a good one, which is you can see a walking path along here, that lighter line. What we're showing on there is louvers. I mean, these are solar panels that you could possibly put on. These are those daylighting windows that we're going into the space, and then these are louvers. And we're going to need a lot of louvers because we've got to move quite a bit of air through these buildings for safety reasons. And so the nice thing is that you can access these louvers and machines from the roof itself. And I'm going to just run through the other versions. Like I said, we've been moving away from CMU and brick veneer because of some of the difficulties it's presented. So we looked at those composite panels, and these are the exact same views again, just with a different cladding system. This material does best in grays, and it came out a little bit, it was very similar to the CMU, and we thought it added a little too much what was the word you used?
Modeled.
Modeled, yeah. So, but we tried that on all 3 views to see what it would look like. And then,
This is Wayne's favorite version.
and then finally, we tried putting the wood composite product on the entire building, including the process and the lower areas. And this is what it looks like when you do that. And I'll scan around just to show you the other views. But we really, we thought it was nice that you shared materials, but it really differentiated between the office and the more areas that people would be, and then the more industrial areas. And this is what it would look like from back of house.
That's beautiful.
What's the cost difference on this? Because that wood look is gorgeous. Is it a huge difference
Between the brick, the fiber cement composite, and the wood composite, the materials are very close in cost. The undisclosed things are that some of those materials are heavier than other materials. So when we start putting brick or CMU on a tall wall, for instance, the foundation system and the structural system associated with that actually add cost. So even though the materials are around the same cost, there's some other factors that we'll be looking at next time we do a cost estimate. But the material cost is very close.
Very similar. Interesting. That wood tone has a nice look.
It's beautiful.
River Road view, yeah. So, back up.
Oh, sorry. Which one?
Back up, that one. So at this time, I guess the feeling from the design team is that we're sort of partial to this one, but wanted to get your feedback at this time.
I'm
Before we-
partial to that, too.
Okay.
Guys, basically, we'd like to have a consensus from you all on where we're at with the building before we move into the final design. There's the variety of different color schemes that you can do with this, but this is what really struck us as a nice-looking building, as well staffed. I think they've done a really nice job of working it out, and we are very conscious of cost. We were asking that is a big component of this. And when we determined that they were relatively the same in materials, it's like, well, let's make it look as good as we can make it.
When you said the wood composite is long lasting, what does that mean?
Well, initially, we started off this project with all wood on the outside, actual wood, cedar, or something like that. And this material is something we've seen on Portland buildings now for 20 years, and they look the same as they did when...
No maintenance.
With no maintenance. Anything that's exposed wood on the outside of this facility, of course, would need maintenance. And even though we love to maintain wood buildings, right? But the inside is all, glue lams and post and beam timber kind of construction for the lower parts. Anyway, I hope I answered your question. It's a long-lasting material. I don't know exactly, at year 59, will it fall off the building? I don't think so.
I'm calling you.
You said 20 years was it, though.
On this view here, are windows supposed to be on the tall side? I can't, because I don't see them there. I don't know, am I just missing it? Or were the windows on the sides? I thought the windows were on this tall side here. Are they just not shown in this?
No, are you referring to this as the tall side?
Yes.
No, the windows are intentionally on these end
sides.
pieces.
Okay.
Well, one of the big advantages is because the sun is pretty low in the sky here, we can add a little bit of insulation to this portion of the wall, and it will actually, we intentionally didn't want to put windows there because we want to suck up as much heat as we can in the building right there and save the apartment from heating up. So
It's a
strategy we took.
Are we looking at
it's a great place for, that's the south.
South, okay.
Exposure. Yeah, it's a great place for photovoltaics, it's a great place for hot water panels as well.
Okay.
But it's also a great place to maintain those things if you're walking around on the roof, so. Okay.
So we want a strawberry mural on this.
That's actually...
Well,
He does not speak for all of
and the
us.
thing that I like about the wood tone is it fits in a residential area where this is going to be. It is more natural, and I think it's got a really good look. It doesn't look as industrial.
Yeah.
Our architects have done, and our staff, in my opinion, they've done a really nice job of trying to fit a building.
Yeah,
They
looks good.
really took the time to learn the area, and, yeah, when we saw this, we were all like,
Yeah.
that looks like the one, but we want to make sure that that's our option, but we'd like to have council's buy-in on that as well, or something different.
Any other comments from council? You guys, you like that design? Good.
I like the wood.
Yeah.
Thank you. Want to go to the raw water pump station?
You can, but
We're going to need to finish
we're
up here.
about it at times, so what I'd like to do is if you got
Yeah, if you got any questions.
any comments or questions for us, it would be good for us to have.
Can I mention one more thing before we get comments? There is a water, the pump station component at this point with permitting has gone in as a CMU building. This could be any cladding element either, so I don't know how you feel about a masonry product versus this wood product on this building, which is about a mile away.
Yeah, our proposal would be to make it look like a campus, so the water plant and the raw water pump station would be, and so we'll come back to them and ask for a different siding. The style is styled after the, you can see the hip roof type. This one doesn't lend itself to the frame type structure because it is just a pretty standard roof.
Yeah, pump station construction is very simplified. Oops. But we did wrap the roof here to sort of bring it in the same style as the water treatment plant. Good?
Any other comments, questions that we can respond to as we move forward?
We'll have several other agenda items tonight if you think of some.
Very good job. Thank you.
Thank you.
Great.
Thank you.